In this episode of Cube FM, we're joined by Grzegorz, a Kubernetes engineer at Cloud Kitchens, to break down the complexities of running Kubernetes at scale. We'll discuss self-healing frameworks, multi-cluster management, and optimizing managed services like AKS. He shares how his team mitigates spot node preemptions, automates failure recovery, and deals with issues like unbalanced IRQs causing network packet drops. We'll also examine workload-level automation from CPU throttling noisy neighbors to capturing money dumps for debugging. Additionally, we'll explore how Kubernetes default handling of unreachable nodes impacts stateful workloads and how custom automation can prevent downtime. Finally, we discuss optimizing cluster stability by proactively cleaning up orphan pods and tuning Kubernetes scheduling behavior for high-efficiency environments. This episode is powered by LearnK8. Since 2017, LearnK8 has been helping Kubernetes engineers level up all over the world. From Fortune 100 companies to small startups, LearnK8 provides training in person or online to individuals as well as groups. Courses are instructor-led, 60% practical and 40% theoretical, and students have access to course materials for the rest of their lives. For more information, check out learnk8.io. Now, let's get into the episode. So, first question. What are 3 emerging Kubernetes tools that you are keeping an eye on?
Okay, so for me, it's Coroot, which is the emerging open source tool for doing kind of APM stuff like New Relic does, but it's completely open source, and I really enjoy seeing them grow because I've been experimenting with it. I gave some feedback to the team. I created some issues on GitHub, and I really see how they are improving it from version to version and just updating it. Second thing is the SIG multi-cluster and in general cluster inventory, because many places we see this need to focus on managing multiple Kubernetes clusters, like with the hub spoke architecture or similar. And I see this repetitive patterns that many companies and many people do this kind of stuff of managing multiple clusters from single place. So I'm really interested how it can simplify these use cases. And the last thing which I looking at is Basma, which is interesting technology. I see a lot of potential there. However, I'm more curious to see how the actual production use cases look like.
To move it over to you a little bit more, can you tell me about who you are, where you work, and what you do?
Okay, so I'm Kubernetes engineer at Cloud Kitchens, and my day-to-day job is working on creating a reliable, scalable, and cost-efficient platform for the company. I do my best to enhance the platform visibility, reliability, and automation, also keeping the cost and efficiency in mind. Additionally, my team is providing technical expertise regarding Kubernetes or cloud-native technologies to the rest of the company.
And how did you get into cloud native?
So actually, I started as a Java developer, and a few years ago, I had a chance to transform one application which was running on the legacy OpenStack to run on our new Kubernetes platform, and I really enjoyed this. I learned a lot about Kubernetes during that time, and I wanted to stay in this area because it was much more appealing to me than writing Java code. So later on, when I had opportunity, I switched to the tooling team, which was newly created and focusing on developing tools around our Kubernetes platform back then, mostly including Prometheus and writing some first operators. Back then it was in Python. And later on, the team focus shifted to be more, let's say, product specific. So I was looking for a chance to stay in Kubernetes area. So back then I found a role in Cloud Kitchens, which I'm currently in. And also in the meantime, I took over the kind of abandoned open source project called Meta Controller, and I'm still maintaining it in my free time. However, I do not have as much as free time for doing that as I would like to, so, but still keeping an eye on it.
What were you before cloud native?
Okay, so as I said, I was a Java developer and I started in 2011 and I worked on variety of projects from desktop application related to testing, code coverage, and unit test generation for Java code. Later on, I worked on integration layer between old and new system using Cassandra and Kafka. But to be honest, I don't really miss that part. It was valuable experience, but now working in platform and cloud native stuff, I must say that it's much more appealing to me. And one thing which I learned over the time is that being in this place on the platform team gives you much more bigger impact area, and you can reach more people to when you're working on platform components, and whatever I do here can impact the whole application stack, which is really amazing.
Excellent. Now, the Kubernetes ecosystem moves very quickly. How do you keep updated? Do you read blogs? Do you watch videos, listen to podcasts? What works best for you?
Yeah, so as this is very broad ecosystem, I mainly focus on reading usually Kubernetes release updates just to know what's graduating, what's new coming to Kubernetes. I try to stay on top of Learn Kubernetes newsletter, as well as few Kubernetes Slack channels, usually related to controller runtime or KubeBuilder or things like that. And also in a few Kubernetes 6 like SIG multi-cluster and SIG node, mainly just reading what people wrote there, but it's really amazing experience which gives you a lot of visibility on what's happening under the hood. I also try to stay on what's happening at KubeCon, and when I cannot go by person, I just take a glance look on the agenda. I just pick interesting talks to watch later on YouTube.
And if you had to go back in time to share one piece of career advice with your younger self, what would it be?
So for sure, it would be don't stop on the documentation, do more, exploratory work, experimental work, go through open source code, try to do some experiments, and look for opportunities to contribute to open source projects, because it's really great, great experience. And yeah, it's also kind of, rewarding to know that your stuff is used by other people.
As part of our monthly content discovery, we found an article that you wrote titled From Fragile to Faultless, Kubernetes Self-Healing in Practice. So we wanted to get into this a little bit more. Many people say that using a managed Kubernetes service like AKS makes everything easier. In your experience, is this really the case?
So yes, using managed Kubernetes service like AKS makes things easier, because it takes a lot of the work which is needed for set up the cluster and operating on the cluster. However, it also comes with its own set of challenges. When we moved to AKS, we focused on making our setup easier. So for example, we used open source projects like Kapi and KapZ, which is Cluster API, and it's provided for Azure to automate our process. And it was really speeding up the pace of onboarding new clusters. However, at the same time, we had to do some contributions to KapZ and Kapi to enable more customizations and fix some bugs which impacted our environments. Also, managed services like AKS have, they need to support a variety of different use cases. So they usually tune to the default settings, which might not be suitable for every use case. On our side, we needed to customize like cluster autoscaler and create a custom scheduler for better node bean packing to be more, let's say, resource efficient. Also, for our multi-cluster setup, we wrote kind of manager to handle the updates of the node pools to make the process easier and more reliable. And despite those efforts, we or everyone which is using the managed services is vulnerable to issues which comes from underlying infrastructure or cloud provider. And it's expected. Bugs and incidents can happen to anyone. However, ensuring business continuity often means that you need the control in your own hands. And this is important because, waiting for fix done on cloud provider side and just rolling it out to every region and every environment also takes time, and you need to be able to survive till then. And yeah, I want to notice that cloud providers are continually improving their operations, which also reduce some of the issues which we will be talking about. But they also enhance their monitoring across different areas, which makes the observability easier. Also, at some point, you need to work with cloud provider because you don't have access to, let's say, etcd server under the hood. So during one incident when we had this, let's say, process just filling up etcd, we needed to work with cloud provider that they can just remove objects directly from etcd, which we cannot do on our own. On the other hand, some decisions made by cloud providers like Azure directly affect us, and they are hard to work around. For example, recently we discovered that when you have a NAT gateway and you try to connect to the AKS cluster, Azure Networking classifies this public IP of the API Kubernetes API server as an external public IP. So as a result, all the traffic generated by Kubernetes system components or controllers just using the watch pattern is classified as external internet traffic, and it's charged, accordingly, which is not the cheapest one. Another example is lack of control of the beta features in the cluster. So if the beta feature isn't enabled by default in Kubernetes, you cannot just enable it on your own in, let's say, Azure. You just need to wait till the feature will graduate, which, well, it's not optimal. We would like to have more control over those settings.
Your article discusses challenges with managed Kubernetes distributions like AKS. Despite their ease of setup, you've encountered various issues. Can you elaborate on these challenges?
Sure, but let's point out that not all of the issues are directly related to managed Kubernetes. Some of them are just, the consequence of some decisions or how Kubernetes is set up in the first place. So, for example, let's take a look how Kubernetes handles unreachable nodes, meaning that the nodes to which Kubernetes API server can connect to. By default, Kubernetes adds 5-minute toleration to the pod to survive or node with unreachable taint. And after 5 minutes, pods are removed from the API server and gets rescheduled. However, this not apply to pods which are managed by StationSet. And on our side, it goes under application issues with workloads like CockroachDB or OpenSearch. Another example was increase in packet drops for our network sensitive workload. It took us a while to, discover that it was caused by, or it was related to nodes experiencing a freeze event, which means that the cloud provider just moved the VM under the physical hosts, under the hood. And I guess most people didn't notice this because they didn't beam pack their pods onto nodes in such effective way as we do, because you can easily, spread up the pods to different nodes and just never be hit by this issue. So it's not that everyone will suffer from the same, let's say, issues. Despite the fact that not everyone, will suffer from them. In our case, we suffered a bit, and it had noticeable impact on our workloads.
To address these problems, you developed a self-healing framework. Could you give us an overview of how this framework is structured?
Sure. However, it was kind of a journey. We started with dealing the problem with was related to the spot nodes. These nodes are, cheaper, but the cloud provider can take them back at any time. And this made us to design a system which is using Kubernetes controllers working as deployments to detect and react to these events, to do some actions to reschedule the pods from that nodes. And it was the first fundament of our, let's say, platform. The second one come from the, let's say, node-centric point of view, when certain group of a problem can be only detected or is easily detected when you have access to the host of underlying node, because it's really hard to capture them just by watching the node metrics or logs. So it just we just use that part to expose some low-level metrics or conditions which needs the host access just to expose them. And if certain condition happens, we just set a label on the node, which allows the second part of the framework to target this node to take appropriate action. So at the end, we ended up with a kind of combined design of daemon sets and deployments, which work together in order to self-recover the problems. Also, we had two main principles. One was to not rely on the, let's say, higher abstraction. So, for example, we just use Kubernetes native labels and annotations and the host's file system. We do not rely on, let's say, Istio or any other databases or caches, which can also go down. And second one was that the automation should not make the situation worse. So do not harm. And this approach is working for us very well. And we still onboarding new use cases if we found one.
Now, one of the first issues you tackled was handling spot node preemptions. How does your automation work in this case?
So as I said, spot nodes are the special kind of nodes which can be taken away by cloud provider at any time. However, there is at least 30-second notification before it's happening. In practice, we saw that it's happening a few minutes earlier. The AKS plugin for node problem detector sets a condition on the node with message starting with preempt scheduled, and that we know that this node will be preempted. However, this condition is set, don't initiate any remediation. So our workload is actually just watching for the nodes with this condition, and then based on that creates a custom resource, which is then captured by the other part. And we try to delete all the pods with 10 seconds grace period to just give them proper way of shutdown. And this really helped us to survive this spot nodes preemptions, as most pods is properly shut down and it's recreated on the working nodes.
Spot instances seem to present ongoing challenges. What other issues did you face with spot nodes and how did you address them?
Yeah, so actually after going to production with these solutions, we discovered that just not all signals we can capture, because simply the underlying Azure metadata service endpoint is not always accessible. So we saw that from time to time, the query to this endpoint done by Azure plugin just types out. So we can miss the signal. And to address this, we expanded our detector to monitor nodes which are deleted from control plane and had the spot label. And then we did a similar approach. We create a CR just to denote that, hey, this node has been deleted, and we need to check if there are any sharing pods or orphan pods somewhere in the API server. And if we found them, we just force delete them, because we just assume that they are not running, so they should be rescheduled. And this makes us to close the gap, and now it's working, I would say, pretty reliable to in case of spot nodes. preemptions.
Moving on to more general node issues, you mentioned problems with stateful set pods on unreachable nodes. Can you explain this issue as well as your solution?
So it was actually interesting challenge, and how it works is that each pod has by Kubernetes added this default 5 minutes tolerations for surviving the no execute timed with unreachable reason for 5 minutes. However, after that time, the pods are being deleted and rescheduled by deployment controller or replica set controller or some other nodes. However, this is not the case for stateful set pods. Stateful set pods have some special notion in Kubernetes, so because they're supposed to have this unique identity, so the stateful set controller cannot actually determine if the pod is running or not running because of some network split. So it just don't do any action. In our case, it was causing the problem because the pods were not running, and our stateful set services like CockroachDB or OpenSearch had this issue with being under-replicated. And we needed to take action to just force delete those pods to enable the stateful set controller to recreate them. And after it happens a couple of times, we just created automation, which is looking for nodes marked with no execute time because of being unreachable. And we just react if this node is in the state for longer than 5 minutes, then just force remove every pod. So they are rescheduled on the other nodes, which allows our stateful set to self-recover. And it's since then we didn't need to take any actions like that, so we call it success.
Now, cluster health can also be affected by accumulated pods. You found issues with succeeded and evicted pods. How did you approach this problem?
It was quite interesting because back in the time we had some struggles with our cluster being a bit affected with a lot of operations. And one of them was because our etcd was kind of growing. So at the time we were aiming different measures to just make our API server lives easier. We found that we have a lot of pods, usually as a result of short-living jobs or pods without controller, or the pods which were evicted because of load pressures like memory pressure or disk pressure. And just the churn of these pods was very large. And also it was not clear for our, let's say, users when they see, 10 pods in the main state. Some of them were completed, some of them were running, so they didn't really know what's happening. So to mitigate all that, we implemented a simple self-cleaning mechanism. Just periodically scans for the pods in the succeed phase or the ones which have been evicted by the node pressure eviction. And if these pods are in the state for at least 15 minutes, we just delete them. And this keeps just our cluster tidy and reduce this unnecessary load on the API server. So we had better stability because of that.
How about we discuss some of the more complex issues you encountered? Can you tell us about the network packet drops due to unbalanced IRQ and how you addressed it?
Yeah, so it was the one which was taking a bit of time for us to actually root cause it properly, because at first glance, it looked at like application issue, because the users were complaining that on their IO sensitive workload had this increasing number of package drops. Initially, we thought that it's related to the user configuration, but it was happening over and over randomly. After more deep look into it, we found that it's usually happening after the node which is hosting those workloads experience a VM freeze event, which, as we know, is related with moving the virtual machine between physical hosts to just mitigate some hardware issue or just to move them because of ongoing update operation. So we noticed that sometimes, or in many times after this operation, the network interrupts were handled by just 1 or 2 CPU cores, let's say out of 16 or 8 or 32 on the node. So it was causing the bottleneck in processing network traffic, which was leading to packet drops. And we noticed that we just need to restart ERQ balance service on the node as systemd service, which is responsible for evenly distributing the hardware interrupts across all the cores. And it was resolving our issue until the next freeze event happened. So we to do some more permanent solution, we set up an automation of the node level. So we detect the number of the CPU cores used for network interrupts. And so we set a condition that if less than half of the cores is used for network interrupts, then just mark the node. And we had another daemon set which was just jumping there and just restarting the ERQ balance systemd service on the node, which was fixing the issue. So, and it's working for at least 1 year, and we didn't see anything like that since then. So I would say it solves our issue.
Developing these automations must have been a bit of a learning process. What are some key lessons you've taken away from going through this process?
Oh, it was. So for me, it also was, going beyond our comfort zone. And this is, for me, the first lesson that I was comfortable working with Kubernetes, but as platform engineers, it seems like, you need to go beyond that. You need to look at your infrastructure, look at, how cloud providers work, how your users use the Kubernetes, and how the network comes into play in, the whole picture. So to fully understand and solve the problems, you need to, really deep down and just go beyond what is your, the best expertise, just to see the whole pictures and to provide or debug the request of the issue. And second learning lesson for me was that, Kubernetes is foundation to build platforms. However, for your use cases or your setup, it needs some, let's say, development. It needs some customizations. It needs to, and it allows to build some automation on top of it. And yeah, in order to tailor, the platform for your users, for your use cases, you cannot just rely on, defaults or whatever comes with cloud provider offering. And the final lessons for me was that if you have all this complexity, like you have the managed Kubernetes, you have, some added add-ons like Istio, you have networking configuration, it's a really complex ecosystem, and you cannot really predict each and every issue. But what you can do is focusing on detecting them and increasing the mitigation time. So whenever they happen, you can easily spot them and work quickly towards fixing them.
Looking ahead, what are your plans for further developing this self-healing framework?
Okay, so I would say that the fundamental architecture is done, and what we are doing right now is extending the particular parts. Like recently, we are using our framework, especially the daemon set part, which is working on a node level, to solve the problem of noise neighbors in our clusters. So we call a workload noise neighbor when one pod on the node is trying to use most of the CPU on the node, which makes the whole node and other workloads unstable in some cases. So our automation, in short, just detects this kind of pods which are excessively using CPU and sets the limit on the offending pod using containerd API, which is kind of throttling the problematic pod, but leaving the whole node healthy and allowing all the workloads, which is working day, to continue operating smoothly. Second issue which we solved recently was related with nodes sometimes misbehaving after a freeze event, which was mainly manifesting at, no network traffic was allowed on the given node. I mean, input traffic was not allowed. However, the pods and processes were able to, go with external traffic from the node, which was creating some weird scenario in our use case. We didn't find the exact root cause for that. However, we noticed when you restart the kubelet on the node, it just fixed the network. So our current automation just watches for the status of the pods. If they are unready because kubelet cannot really go with liveness probe to the pods, we just restart the kubelet, and usually it fixed the issue. And at this point, it was good enough automation on our side. And as I said, we don't have specific plans to extend this framework. We're rather watching for new cases which can be automated using this framework. And for us, I believe it's kind of done job with the framework. And we rather will continue on adding more automations if feasible, because you need to balance whatever you want to automate and not whatever you just need to leave as temporary workaround, because we have also other things to deliver. So it's always a trade-off.
Got it. Thanks so much for sharing these insights. Before we wrap up, is there any advice that you'd like to give our listeners who might be considering implementing similar self-healing solutions?
Well, so main advice would be to focus on optimizing for speed, because you cannot foresee all the issues. However, our framework allows to quickly add new automations. So even though we are not really sure what can come next, we rather sure that we can automate them rather quickly. And this approach for us was more effective in the long run than just trying to predict every failure scenario, every use case with this complex universe.
What's next for you?
The plans, we just plan to focus more on workload related automations, which helps our users to automate things like collecting the heat dumps or memory dumps on the workload level. So when we detect an issue with the workload, we do some automation which helps users to diagnose them. And because we have this platform part already covered, but we want also to cover the users part. So this mainly it's.
All right. How can people get in touch with you?
I have this email address which is shared, I believe, in this video. Also, if you're interested in MetaController project, just feel free to look it up on the GitHub. And if you find it interesting, just come to the Slack channel on Kubernetes Slack called MetaController and say hi.
Fantastic. Thank you so much for sharing your knowledge with our community. Look forward to speaking with you soon. Take care.
Take care. Thank you.